Hello, everyone. My name is Tony Sparks, and this is session 2 of the Block U course. Last week, I signed out some homework for Crypto Zombies. It is a very nice tutorial on how to build a blockchain application slash game. Oh, hey, Stuart, how are you doing? Yeah, I'm mid recording right now. I was just saying, like how we assigned the homework of Crypto Zombies. And then today we'll be going over MetaMask Remix and how to deploy smart contracts to Ethereum's testnet called the Ropsten Testnet.
Hi. Sorry.
That's okay. So the first thing is like, I guess, is there any questions over the homework you guys had?
No.
Okay. All right, cool. Well, yeah. All right. So basically, I can bring it up just for people who want to see it. I'm going to share my screen right now. So let's do the share desktop one. Okay, cool. And then here is basically, so yeah, path, Solidity's path to beginners or intermediate smart contracts. It's basically what we're supposed to be focused on. And like, these are just the various things. I think they're all very nice lessons. So like, ultimately, like the goal of to like this homework, the second homework assignment, is to take like the code that you guys produce here. Ideally, you guys altered it a bit to make it your own, and we deploy it to the Ropsten Test Network. So now I'm going to explain what that is. I think one of the first things that's useful is I'm going to bring up Remix. So this is Remix. Recently, it has had like an updated look. It took a while for me to kind of get used to it, but overall, I think it's okay and cool. So this is like some smart contracts that I have here. Um, at some point, I will be deploying the Block U 721 token. That's equivalent to a trading card. I don't know if you guys are familiar with Crypto Kitties, but like the Crypto Zombies is definitely like along those lines. And you guys are definitely learning about the 721 standard via the homework. But what I would like to do is record all of your assignments, your progress, your surveys, and stuff like that onto the blockchain. So it's like an immutable record for the school and for you guys. And so Remix is like one of the softwares that we'll be using. And so one of the things that Remix has is like different plugins that you can activate. I don't use all the plugins, but like the ones I use specifically is the Solidity compiler and deploy and run transactions. If you click this plugin icon right here, you can see that. And then like you can see the different plugins, you can activate them and deactivate them. I already have these activated, so I'll leave them activated for now. So this is the deploy and run transactions. So in Solidity, in like the Ethereum smart contract development, you have these different environments. Okay. So the environments are like basically like the blockchain that Solidity is running on. Like there's like a main net that's like for the Ethereum blockchain, the stuff that's actually traded on the stock exchange or I'm sorry, cryptocurrency exchanges. Like that is where the main net is, and like the Ethereum block for that, it's like it's for the live stuff, right? So in order to add records to the blockchain and to fulfill transactions, you have to pay the miners gas or ether, right? Gas and ether are basically the same thing. Imagine that if you want someone to drive to like Mexico or drive somewhere, anywhere, they're going to need gas to do it. So that's the actual value of Ethereum and Ether specifically, is that like it is the gas to update the history and the transactions that is the Ethereum blockchain. So, like one thing I want to make sure you guys know is that it's free to read information from the blockchain, but it costs gas to actually update the blockchain. It's kind of like, imagine you have a book, and in order to read the book, it's no effort. Anyone can read a book, that's no problem. But to add a new page to the book, that's where you need the Ethereum and the gas. So all that being said, there is different networks that you can use with the remix. Like the JavaScript virtual machine is like basically like, I guess, the blockchain of this Ethereum remix site specifically. And then you have this injected Web3, which is another environment that comes from MetaMask. So MetaMask is something that like I definitely want everyone to download. That's definitely part of the homework and part of like us continuing forward. And like the value of MetaMask is that in order to like fulfill transactions and cause different things to happen inside the blockchain, you need a specific address and account. And let's see, I want to make sure I can show this without showing anything personal, because like essentially the value of blockchain is that it's secure in that as long as you have a password, that you can like execute different transactions, and that password is the only thing that's that keeps it so no one else can make transactions on your behalf. And so MetaMask, this is like a plugin for Chrome. I think it's a plugin for Brave and Firefox, maybe, right? But I know Chrome for sure. And so here's my MetaMask situation. Like to create a new account on MetaMask, first of all, you have to download it, right? You guys can Google that. I can just show you what it's like to Google MetaMask, right? MetaMask plugin. Okay. I didn't spell that right, MetaMask. Cool. So here's the MetaMask site. You can like click here to get the Chrome extension. If you're using Brave or something else, I'm pretty sure there's an extension too, but like worst case scenario, use Chrome. And so once you do that, then you'll have like this little icon right here. And let's see here. Okay, I'm just gonna click this outside. All right, cool. So here's the pop-up. One of the first things you'll have to do is, let's see here, is click to create an account. You do that, and basically it generates a public key and a private key for you. And like one of the benefits of MetaMask is that like if you ever was to more or less lose your public and private key or lose your laptop where that stuff is stored, you can log in and basically you can type in the seed phrase. They give you the seed phrase when you install it. Like, make sure that you record that, you put that somewhere that you can always have access to it. I'm not going to tell you exactly where to put it, but like, put it somewhere so worst case scenario, you can always find it. And what that does is allows you to like, let's say if you lose your laptop, and you have to like log into your MetaMask like on a different laptop, you can type in your seed phrase and then generate your public and private key for you. And that's very helpful. Like there's definitely horror stories of people losing their cryptocurrency just because they lost their passwords and their keys. And so MetaMask is like a third party that offers the security of storing that for you. It stores on your browser and like not on like their database, so that's one of the reasons why like if you ever lose your seed phrase, then like, you're kind of fucked. So like definitely download MetaMask. I think it's a nice tool, and it's definitely necessary for what we're trying to do. So I have that here. I have my account right here. And so what I'm going to do is like I'm in Remix, and I'm going to switch to the MetaMask Web3. So when it says injected Web3 is a library that it's a JavaScript library and allows you to send calls and read read the blockchain with the JavaScript library. When we get into the realm of creating dApps and actually creating applications that use blockchain, we will need to use Web3 because it's kind of like jQuery in that like it's a library with some shortcuts that allows you to interact with the blockchain. So I switched over to my ejected Web3. It's ejected from MetaMask. Now we can also talk about the Ropsten network. So earlier I mentioned that there's like the Ethereum main network, and if you click this right here, you can like switch over to the main network. They also have the Ropsten Test network and these other networks there too. I only use the Ropsten Test network. Well, no, I don't only use that. Like when I'm like basically in the phase of my site's in staging, right? Or I want to actually test this stuff with the actual network where my transactions are being mined, I use the Ropsten Test network. At some point, we will talk about localhost 8545. And like that is basically like a local blockchain for your computer. The benefit of using these type of local blockchains is that you don't have to wait for someone else or some other computers to mine your transactions. It's actually quicker and it's very helpful. Like definitely in the beginning of me building my smart contracts and my applications, I use a lot of the local blockchain. And like it's generated with this thing called Ganache. I can show you guys that on like a different lesson. But like, yeah, for now, we have this Ropsten Test network. And so one thing I want to show you guys too is how to get Ethereum on this network. You have to go to like a faucet. So I'm just going to type this in. Ropsten faucet. So you type that here. You can go to different types of faucets. Okay, here's this. So it says request Ethereum, and then this is address. So it says from faucet, it says user. So just click this and see what happens. Okay, so I asked if I like to connect. I would like to connect. Maybe some form of an error. I think I remember this last time there was some form of an error. But I don't think that error like super duper like matters. So let's see here. I'm just click this too. All right, cool. So this is confirm. This is from this to that. I think this is me actually giving Ethereum back to them, and I don't think I want to do that. I don't want to send Ethereum. So that one of the benefits of MetaMask is let you like verify transactions. So it says, Ethereum sent. You wanna click this. See what happens. All right, so boom, right there, it added a transaction right there. This is currently my like public balance right here, and yeah. So this is kind of what you have to do basically get this test Ethereum, and then so one thing I want to do here, we'll see, because like usually it takes like 15 minutes or so for these transactions to kick in. It says 11 right here. And then, so boom, my balance just changed. It changed to like 10. So I just gave them Ethereum. I wanted Ethereum, right? So this is basically the button you probably want to click. And this says user is greedy. User has too much ether. So they said, hey, you have too much ether already, Tony Sparks. We're not going to give you any more. And I respect that. When you guys sign up and you guys have your MetaMask, then basically it should give you guys Ethereum. I just gave them some Ethereum. So yeah, this is how you get Ethereum on their Ropsten Test network. And this is why this is useful. So now we're in this ejected Web3. We're on the Ropsten Test network. It says it right there. Here's my account. And so what I'm going to do is I'm going to deploy a smart contract for you guys. So I'm going to deploy this token book. All right. So this is basically like an ERC20 smart contract that I created. We're going to be recording your records on the block use ERC20 token. So I'm going to show you guys like how I would deploy this. So first thing I'm going to do is I'm going to come over here. So this is deploy and run transactions. So it's using the right network. And this is basically all the smart contracts that I currently have under this file. So like, for example, first I want to switch this token book. This is the one I want to deploy. You select the contract you want to deploy, and specifically, it's this contract right here. It says token book. And so what's cool about Ethereum is that your contracts can basically inherit properties from other contracts. I would equate it to something like having an abstract class and then having classes that extend it or that use that abstract class. Or I can equate it to like, let's say you have a class called car, right? And then you have a specific type of car called Maserati, right? Maserati will basically be an instance or a type of car. And so like the Maserati would then inherit all of the features of a car, like wheels and transition and like different stuff like that that's necessary. Okay. So, all that being said, like we have this token book. It inherits from the standard token, the meta, and the meta token. These are other like smart contracts that I created specifically. Like the token or standard token may be something that I altered from somewhere else. But the fun part, right, is us, deploying the smart contract. So like there's two types of ways to enter in the string. You can type it in right here, but if you have like multiple things you want to type, you might be better off doing this. And so I want to say test token. And then I'm going to click transact. So now MetaMask is going to ask me to confirm this transaction. I'm going to click confirm. All right, boom shakalaka. So right here we have in this console, it's showing that it's mining this transaction. It's pending the creation of this, and eventually when it's ready, it's going to show up over here to the left. And then when it shows up, I'm going to show you guys how to interact with it. While that's happening, I can show you guys some features. Like there's this public string called name. There's upgraded address. Like I think it's definitely wise, like when we get in the knack of creating contracts, is we prepare for a potential upgrade that has to happen. Or let's say for some reason there's a bug in the smart contract. Because the way this is blockchain and the way this works is like once you upload some code to the blockchain, you can't change it. That's like the value of it too. So like if you have like an agreement that like, you basically don't want to be changed or altered, then you upload it to the blockchain and then it will stay there and no one can ever change it. But if let's say you upload a bug to the blockchain, then you're kind of, in a situation. So having like a way to forward other transactions to an upgraded address is very important. And in other lessons, we can definitely talk more about that. Okay, so here is the smart contract that I've deployed. Here are the various features and functions that it has. Notice that like all of these features and functionalities are not in this immediate smart contract token book because they're like inherited from other contracts. So, quick proof of concept I can show you guys is this. Like it has this name that I initiated when I deployed it. Just to be clear, there is this thing called a constructor, right? A constructor is like the function that runs when the contract is initiated. This token book that we have, it extends what is called ownable, which is another contract. And basically ownable makes it so whoever deploys the contract, their address is listed as the owner of the contract. So the proof of that is this owner function right here saying, my Ethereum address. This is my public address. And so one thing I would like to show you guys is there's two types of like functions or buttons here in this the smart contract. You have what is called callables or reading functions. This basically reads data. This is free, like I said, and it's not trackable too. So that's to be noted, right? Like basically if someone reads data a whole bunch of times, it's not like a coordinate somewhere. So if you want something to record something, basically updating the contract, then you have to like use these type of functions, which these are like, these are transactions that affect the blockchain. And that's why they're this color. So let's see, for example, right? So this is basically in the act of like, let's say, hey, I want to create a token for you guys. What does that mean, right? So first thing I'm going to do is I'm going to add a token, right? And what I have over here is like, there's an owner, there's an admin, there's a manager, and then there's the data of the token, and there's metadata. So to explain what this is, the owner is like whoever owns the token. Like they're allowed to basically transfer ownership of the token. They can add admin, they can add managers. An admin is someone who doesn't own the token, but they can affect the token and change it, like add pages to it. And then a manager is somebody who just has access to read the token, and they can also like make other managers and stuff. Or specifically, they can just read it. Like admins can make other managers though. Owners can make managers too. So I'm going to go and I'm going to create this token. So first thing I'm going to do is I want to get the owner or get an address. And this is the address I want to use. This is my address. I'm going to enter it as the owner, the admin, and the manager, the token data. So the token data is going to be a public record that anyone can kind of see. If they want to figure out what's in this token, what is this token about? Basically, this is where you want to do this. So I'm going to say public stuff. And then this one is like more or less private stuff. I want to like definitely be clear what I mean by private. So it is a private variable. And it means that like basically no one can just see it, right? Like the way I have my code is like if you're like an authorized user, like an owner or admin, if you make a call to read this data, then you can see it. But if you're not, then you won't be able to see it. But that doesn't completely mean that what's in there is completely secure. Like, let's say, God forbid, someone's able to kind of like decode the blockchain and figure out like what these hashes mean and what data was entered based off of that. Then like it's possible that what you call a private variable could be seen by somebody. So that's why, like, in us doing stuff, I definitely, if we want to keep something like super private, like let's say it's someone's like data that's super like private or some shit, we want to encrypt it even on the blockchain, just in case, like worst case scenario, someone sees it, then like it's still, you need like something else to actually read it. That's how passwords are kind of stored in databases. So I'm gonna click, private. And then I want to show you guys some stuff. First thing I'm going to show you guys is tokens, right? So I'm pretty sure the way this contract works, I can verify this stuff for you guys too. Add token right here. And then constructors right here. Yeah, so when I construct this, I automatically increment the meta page cursor, which basically means like, I make it so the index of the token index that kind of records, which index of the tokens that we're on. Instead of the first one being 0, it's 1, right? And that's because I incremented it. Initially, this meta page cursor was 0, but when you construct it, I added so it's 1. So theoretically, when I create this token, it should be under the token 1. And to kind of show you guys what's going on right now, see it says empty string, is like there's nothing there, okay? What I'm going to do now is I'm going to click this add button. Click transact. All right, so then I'm gonna do confirm. All right, cool. So that's being added. It's a transaction that's taking place. All right, boom. So we just got some confirmation it got added. So now I'm gonna click this, which is boom. Yeah, Tony Sparks. You know, I'm out here, do blockchain stuff. Sometimes when I click buttons, they work, you know. So yeah, there now we see the public stuff that's in the blockchain. And you know, like, so let's say this is like a Block U student. What would that say? I would want to put a JSON there. And it's going to say like student name. And it's going to say like Stewart or Dev Mallet or Whitney Lubin, right? And then, you know, if you want to see more stuff, right? So like, let's say the concept of like submitting homework, what is that going to look like? First thing I want to do is I'm going to try to read some information. So I have this dictionary of meta pages, right? And this is just for random information and random strings and stuff. Like this could be your grades, this could be whatever. It's going to be JSONs is what I want to put there. So I'm gonna get a meta page, but specifically, let's look up get token meta page. So every student is like a token, right? And so like what I put here is the meta page, the meta data index. That's like the token ID, right? So we just created a token with the token ID 1, and then it says meta page. I want to just add 0. So 0 is like the first page. Like the nice thing about this, right? And this is like low key why, you know, at some point, you know, when we start doing market application stuff, we have to look at, you know, some form of confidentiality or something more or less. Cause like there's a lot of like nice nuances that I added to my tokens and my contracts that has like multiple uses. And like, you know, honestly, I think that what I'm producing, I would like to become standards. Like example of a standard is ERC20 token. And you guys may have heard that before, but like basically like way back when like, you know, 2008 was a thing and everybody's making like, you know, their own tokens. They were making what's called like ERC20 tokens, which is like, imagine it's like a class, right? Like, you know, in regards to the early example, the car class, Maserati class or whatever, it was a specific type of class with a specific type of functions like transfer, like get owner, get balance of, you know, very standard things that, you know, you would need to do for a token, right? And, you know, the ERC20 standard was like, you know, one of many standards. Like the 721 is another standard. And so like, I feel like I have some standards that I created that like are very useful when you put them all together, you know? So I definitely look forward to teaching you guys that. And then at some point, you know, we can make this like a well-known standard. And if someone wants to do like our form of business, or like, let's say when we start talking about crowdfunding stocks, then they would be using like our standards. And like, if we ever update it, then like, you know, they have to come for us to the update. You know, I would equate it to being something like jQuery, right? Imagine jQuery version 1's out here, but like, you know, they come out with a version 2 or 3. You know, you're going to want to use that because it's like an updated version of shit. But like the people who created jQuery have the power to kind of like push that out there. So that's kind of like what we're starting here. You know, I think we can start something like a programmer's guild. So anyways, all that being said, here's the first page and I'm going to try to read it. And this is 0, right? So I'm going to add a page. Add token meta page. So I'm going to add, this is for 1, token 1. And then I wanted to say test. Okay, I'm gonna hit transact. Now this is, you know, theoretically would be like a JSON with you guys scores or like with some work you guys did or some notes of what you guys did or like one of the surveys you guys took. I'm gonna click confirm. Okay, cool. And then it's going to do stuff over here. So this is basically, we're in the process of waiting for this transaction to get mined. All right, cool. And then so the same thing we just punched in here, and now it says test, right? So that's another good thing, right? Like it worked. You know, I built that. I did this. I'm happy I can teach you guys some stuff. There's way more where that comes from, you know. That's how I do it. I create stuff that works. You know, I do videos. I teach other people. You know, get all this power together and change the world. Okay, so you know, boom. You know, that's how the BlockU badges will work. You know, that's how I want to record, like what you guys do. I have a specific type of another kind of contract or standard I made, where like, and this is something I more or less have to update. So here's a cool learning point for you guys. So you can't just throw all the data or all the functions, all of the shit in one smart contract. They don't like that. Like there's basically like a finite limit or size to every smart contract. And I get that, you know, respectively, you know. But like you can't throw all the information in the smart contract. So therefore, you know, sometimes you have to break it up, right? Like I have the way that I'm gonna start teaching you guys how to do stuff is I would equate like what I create is something like a body, right? And the body has different organs, right? And the organs are different smart contracts. Like one smart contract may be responsible for storing like pages and information. Another contract may be responsible for like, you know, actual tokens and like, you know, token ownership. I created like a bank smart contract. I'll show you guys at some point, right? But like all those different contracts, if you like code it correctly, they can all work together like they're in one body, right? And basically that's necessary because there are these constraints of these smart contracts. You can't just stuff all this information in there. I know I've tried really hard and it was just like problems. So then I invented the organs and like, it's a smart way to do stuff. I really think so. And it makes it really so like, let's say you have an organ like a kidney or some shit, like, and it's just fucking up or has a bug in it. You can just replace it and then the body keeps moving. All right. So all that being said, I have the specific organ that records not just like pages, like strings. It records smart contract addresses, which brings me to the homework, right? So what I would like for you guys to do is take all this stuff from Crypto Zombies that you guys created and alter to make it so it's your own, more or less, right? And then like go to Solidity or Remix and like, you know, add the different pages to it. I want you guys to take note of this, right? This import situation. So utils.sol is another smart contract I have. It's this one specifically, right? It has stuff like safe math, which is useful for making sure that negative numbers don't get added to, you know, your equations and stuff. And that's like negative numbers are definitely like a threat in regards to like cryptocurrency and like tokenization of stuff. Because, you know, let's say for some reason there was like a negative 100 balance somewhere. And then now like there may be like 100 Bitcoins in total, but that negative balance made it so it's zero. And that just fucks math up. You don't want that to happen. So you have the safe math situation. But yeah, so it just has that, right? But and this is in utils. I'm gonna show you guys this real quick too. Let's say you wanted to make like another file, like, you know, the zombie stuff or whatever, or I'll just call this test for now. All right, so this is a new file. And what you could do is, you know, you put your code in here, blase, and it goes in there, blase, right? And then let's say you have your actual contract, you want to import this, right? This is how you would do it. This is the format for it. You know, you have the import, and you have the dot, then the slash, then the name of the file, and then dot sol, right? And yeah, so like I definitely know in your homework there's different files, right? So what you want to do is click this button like I did over here, copy and paste the code in here like I just did here, and then like whatever like contract you want to deploy from, you know, make sure it has the links in here, and then you can go to here to deploy or specifically, no, here, deploy and run contracts or transactions. So then also, just so you see this, I definitely recommend the Solidity compiler. There is something I want to make sure you guys always know, right? And that is ABC. No, ABT, right? Always be tested, right? And this compiler does that for you. It does this auto compile. Like as you guys are typing stuff, like I've definitely been in situations where like I've typed hundreds to thousands of lines of code, right? And then I put it in this compiler and there's just so many bugs. It's terrible, right? Don't do that to yourself. When you guys write code, I recommend specifically the Solidity stuff, right? You guys do it inside this IDE, right? And then make sure you turn on auto compile. And then it makes it so as you guys like create stuff, if it has a bug in it, it tells you immediately, you can fix that immediately, as opposed to waiting until, 1,000 lines later and you're just like, damn, all this stuff, right? So definitely do that. And as you guys reach milestones, like definitely take the code that's inside of here, copy and paste it into whatever IDE you guys are using. I like Visual Code. It's very, very nice. And then save it, right? Because this shit would betray you, right? For some reason, like this may close, and then some code you guys wrote is erased. And if this is the only place you guys have it, you're fucked. You don't want to be there, right? Don't be there. So definitely have the stuff in Visual Code. But definitely write here too. Keep it in here, write it. And, I'm not going to front. Like, this is definitely saved my smart contracts for a while. These have been here for a while. I close the browser, come back, they're still there. But I don't trust it, Don't trust it. So let me see. I want to review the syllabus real quick. So we talked about Remix. We talked about MetaMask. We talked about the Ropsten Test Network, right? So the homework is to deploy your code to the Ropsten Test Network. And then there's the hands-on, I think it's supposed to say path, make and deploy a custom game mode, right? So I think that's basically it, right? You have this MetaMask to make your accounts. You have Remix to deploy stuff. You have the Ropsten Test Network to test things. I think I'm going to keep our BlockQ badge on the Ropsten Test Network only because it's free. And I'm pretty sure it's not going to go away anytime soon. I'm barely sure about how that works. They said like basically developers need something to test with. There's even talks about people paying money for Ropsten like Tether or Ethereum, which is kind of stupid because it's free. But I don't think the blockchain is going away anytime soon. So therefore, we can use that to kind of test. And like, in the back of my head, I suspect that if I ever want to do something that involves blockchain, but I don't want to have people pay Ethereum, or me as a business, I want to pay for Ethereum, I might do it on this network, right? So we'll, I don't want to say do that for sure, but I feel like it might not be the worst idea. So all that being said, do you guys have any questions?
I have a question.
Yes.
What happens if with like debugging? Like, what's the best method to like address your bug?
Okay. So to debug, all right. So there's a video specifically on the BlockQ curriculum. Let me pull that up real quick. So we do this. Debugging is a bitch too, man. Like it's definitely not where it should be, and it is what it is type of thing. But as I started this, it was such a problem. All right, cool. So we are here. There's this, there's that. Solidity tutorial. How to debug smart contracts, right? This video right here will help you guys with that. And so essentially, like the long story short element of it is, first off, if you guys are debugging, you do want to do it through the local host that I mentioned in the beginning of the video. Ganache specifically was what it is. In this tutorial, they show you how to install that and set that up. If there's any problems with that, definitely let me know and I can help you guys with it. And like I say that because, you guys want to have to wait, if you're in the process of debugging stuff and like you have to wait 15, 20 minutes before the transactions get complete, before you can see what happens, like that's a trap, man. Like it's definitely a waste of time. So I would recommend definitely like download a local blockchain environment. But then also, so like, in this video, it's going to talk about like, let's say there's a bug where it's like a math error, right? Like you expect, 1 + 1 = 2, but it gives you 7 for some reason, right? What you would do is you would take specific values, like, like let's say it's 1 + 1, like you take one of the values, let's say it's A + B, right? And you would emit that value in an event, all right? Now, an event is basically something that in the process of the smart contract doing stuff, it emits certain information out of it, right? And that certain information, you can easily put like values to double check what they are. So let me try to pull up one of these events. Let me see if I can do that. So we had a let's see, we have add token meta page, right? Let's see what this looks like. So I'm gonna click, so it says debug right here, rightfully so, right? It has this information, it has logs, okay. I'll accept that. I might not be in any events right now on this. Let me double check. Let me see what my code says. So add token. So this is here. Okay, so it emits add token. All right, so this is supposed to be an event actually. One thing I learned about this too is like, this remix has some bugs in that, like, even like there's supposed to be like a add token event emitted here, and it doesn't completely show that here. And that is like not ideal per se for sure. There is this other thing that I used to use, and that was very helpful for that. I'm gonna pull it up right now. I just want to verify. Okay, I'll pull this up. Now this is something that like I think I stopped using because I think it was kind of buggy at some point. It's like Pragma. Actually, fuck it. I'm really going to pull up the video. That's what it's there for.
One of the biggest complaints about getting started with Solidity and Ethereum program, you're going to be doing a lot of local development because then you can reuse the same seed phrase. You run Ganache CLI. But once we actually deploy, since we're on localhost, everything should happen almost instantly. So you can see deploy successful.
All right, so yeah, this is Pragma. All right. In Pragma. I spelled it right. I don't like that. Let me just see if I can get the exact. Pragma. What is the URL? Let me see. Pragma.com. Okay. Okay, do this. Pragma. Say .com. See what happens. This looks interesting. I didn't think that's what it was. I'm just going to do this. I don't know what this .tr is. Definitely when I was debugging stuff, this was very helpful. I'm like slightly offended Remix just doesn't have like a better UI for finding the events. While that's loading up, I'm going to just kind of go through this for a second. So it says transaction. So that's the meta tag. Okay, so it's this. Get token. Oh, it says get. All right, hold on. This is this. This is that. So this is add token pending. All right, cool. So this is here. Okay. Okay, cool. Let's see what this says. I'm gonna click this. Yes! I'm so happy. All right, cool. This is the shit I was looking for. Fuck Pragma right now. Look at that. You see this? How it says token owner, token admin, token manager? That's the event that was emitted, right? So to answer your question, you debug by emitting these events like so right here on screen as it says it. And then you look and see what the stuff says. And ideally it says what you wanted to say, or if, there's a problem, then it says what the problem is, or it says, it says some stuff that you then use to logically debug. Does that answer your question?
Yes.
Was that a yes?
Yeah. I was really I was just saying I was just looking to see like just like how you did it. So you just kind of just like went through it. So yeah.
Yeah, man. Debugging. Oh my God, man. Like sometimes there's an error and it doesn't tell you why the error happened, right? Which is why actually, so there's let me see. There's definitely a way to detect, to put in your own error messages, right? Look here, right? Require. So it says require A is smaller than or equal to B, right? This is a subtraction situation, safe math. But then it says this comma right here, and it says cannot subtract these values, right? So that's like, I think that's something I added there, just so like, when I do get an error message, right? Let's say I try to fulfill a transaction, it's like, there's an error. Because sometimes it will do that, right? Before, and I think it's before a specific update in Solidity, it wouldn't tell you why, what the error was, right? But this like little update that they did lets you at least say, okay, if there's an error, then you can like admit what's going on. So you don't have to go through so many different like functions and shit that happen. It's, basically do your own stack trace to figure out, what caused the error. Are there any other questions?
What if like I deploy a contract and like I guess it's just like an error. Or is there what I don't know, I guess it's just an error. Oh.
Okay. All right. Well, I'm going to accept your silences as the lack of questions. Like there is no current questions right now. I'm going to give you guys 5 more seconds. Okay, so we're proceeding. I think we're done. I think that's it. So yeah, the homework is basically take the Crypto Zombies homework you guys have, make it your own, deploy it using Remix, download MetaMask. And that's basically it. First, send me your code, right? Email that to me, right? And then also when you guys deploy the Remix, send me the hashes of all the contracts you guys created. So here is an example of what I'm talking about. So this right here, this is a contract I created. If you click this copy thing right here, then like it says a copy to the clipboard, and just to paste it in this URL real quick, boom, That's the hash. That's what I want, right? So for homework submissions, I want the actual code, and then I want this hash that was generated by the smart contract. And what I'm going to do is I want to, look at your code, see how things are going, right? I'm probably going to grade it. I don't know what I want to do is pass, fail, or give A's and B's. I think pass, fail, right? From a developer's perspective, it's either you did the job or you didn't do the job, right? So like we'll do pass, fail, more or less, right? And then, we'll take this hash that you give me and I'll add it to your badge. And so basically, as you guys deploy all these various smart contracts, I'll have the hashes there next to your badge too. And then if someone wants to like document and figure out, hey, what did you do in block U? You can say, here are all my homework assignment, here are all these hashes. I have the code to make these work. And there you go. And there's documentation. And we use blockchain to do it. So that's basically it. Deploy this stuff, send me the hashes, send me the code. That's homework number 2. And then also definitely do the next installment of Crypto Zombies. So that being said, I'm down to conclude this session. I already want to thank you guys for your time, your efforts, and having any questions. I will also say that I will be sending out a survey pretty soon. So I'll just request you guys fill that out too, and then we'll also document that in the blockchain. Okay. And this was recorded. All right, cool. So I'll post this on the site. Like the first one is not there yet. I will add that too. But like, this is definitely something where like I would imagine you guys will have to come back and review this, just to make sure everything's like what's what, and like, any questions that you guys are scared to ask, you can at least like, check and see and go over it. Like this stuff isn't complicated. I believe in you guys. You guys are smart people, and I'm very confident in this group. Okay. So I'm gonna include this. I'm gonna leave. Is there anything you guys want to say before I go?
Just verifying, we're just going to email you the code and the hash generated by the
Yep. Yep.
Thursday, or just like have it to you before class?
Yeah, this is definitely due by next Thursday, right? So that's it, right? Like, every time I assign homework, it's definitely due the following week, and that's pretty much it. Okay. Well, that being said, I hope the rest of your days go well, and thank you so much for your time.
Thank you.
Thank you. Bye.
Okay. So I'm gonna do this. Do that. I'm gonna end the meeting. All right. Peace out, guys.
Peace.